Так, ну что, мы вроде как в эфире наконец-то. Всем добрый вечер. Добро пожаловать на первый в этом году виртуальный митап московского отделения OWASP. У нас сегодня очень интересная тема. Я рад, что она наконец-то появилась. Это OWASP SAM. Не так давно, в конце мая, прошел OWASP User Day. И вот у нас такое хорошее продолжение получается. С нами сегодня Ян Кравченко. Это один из контрибьюторов проекта OWASP SAM. У него огромный опыт в application security, и мы очень рады, что он согласился выступить сегодня перед нами. Собственно, слово сразу передаем ему. Важно отметить, что, как мы уже анонсировали, сам доклад будет на английском языке. После него будет сессия вопросов и ответов. Она уже будет на русском. Вот такой сегодня у нас порядок. На этом я передаю слово Яну.
Большое спасибо, Тарас. Добрый вечер. Ну, для меня доброе утро, для вас добрый вечер. Заранее благодарен за то, что сделали это в благоприятное для меня время, чтобы не нужно было слишком рано вставать. Заранее извиняюсь, большинство этой презентации будет, безусловно, на английском языке. Я уехал 30 лет назад, поэтому разговорная речь осталась, но, конечно же, говорить на теме настолько сложной, на русском языке грамотно я уже, скорее всего, не смогу, так что приношу свои извинения. Но также, к сожалению, спешу напомнить, что SAM до сих пор еще не перевели на русский язык в любом случае, поэтому, чтобы его вам использовать, все равно знание английского придется иметь. При всем при этом, если есть вопросы, свободно можете их задавать на русском, на английском я постараюсь их ответить. Итак, сегодня, как я хотел преподнести эту тему? Безусловно, все могут пойти и посмотреть на SAM-модель сами, но что я хотел сегодня сделать, это преподнести эту тему на фоне более исторического понятия, что такое application security и какую роль оно имеет, и почему платформа как SAM настолько важна. Я занимаюсь cybersecurity уже 25 лет, и поверьте мне, что когда я начал этим заниматься, понятие software security в принципе очень плохо существовало в то время. И настолько, насколько все эти понятия развиваются, одна из проблем сейчас – это действительно сложно найти людей, у которых серьезный опыт работы в security, и при этом есть сильное понятие о программировании, особенно программирование на более модерновых новых языках. Так что я постараюсь вас провести через всю эволюцию application security programs и насколько вся эта индустрия поменялась, и на этом фоне объясню, каким образом SAM во все это вписывается и как мы именно развивали этот проект, чтобы именно подойти ко всем этим темам и ответить на все вопросы. Obviously, you guys know what SAM is. SAM is a flagship product from OWASP. It has been a flagship project for quite a few years. And our goal is to support application security lifecycle development. The project leaders are Bart and Siba. Both great guys. Siba runs a security consulting practice where they do a lot of threat modeling. Bart works for PwC, I believe, so both of them have considerable experience with application security. Our team is very global and a lot of fun. We have a lot of meetings that we do throughout the years. We try to meet in person as much as we can. Obviously, with the pandemic, this has been somewhat difficult lately, but it is always fun to see what country we're going to choose for our next meeting. Of course, SAM does have sponsors without which we couldn't survive. I'm happy to say that Concord was one of the companies that I brought to the force. So definitely check out the sponsors, helps fund the project. So why OWASP? First and foremost, application development experience is very rare among security professionals. The chances are, if you have 10 plus years of experience in the industry, in security, you have never developed using any of the modern languages unless you made it a priority. When you try to explain software security as a program to very seasoned security professionals, the chances are they don't know what you're talking about. They don't know what Docker is. They don't know what Kubernetes is. For them, a lot of these concepts are very difficult. And so SAM is meant to provide that layer to translate between software developers and security professionals and give a new community-supported force for application security leaders to really help build these programs and organizations. A little OWASP history. The project, OWASP SAM, actually was founded as OpenSAM back in 2009. There was a gentleman by the name Pravir Chandra who worked for 45 Security. While this was always an OWASP project, the way it was developed wasn't very community-focused. It was probably closer to Moses and Sinai, where Chanda locked himself in the room for 2 weeks, and when he came out, he created OWASP SAM 1.0. He did a fantastic job with it. At the time, for 2009, this was a great first effort. It was very much based on software development practices of the day. So very waterfall heavy, and also very inconsistent, where there was a lot of inconsistency between maturity levels. There was a lot of inconsistencies between security practices. And yet still the system worked, and the framework was not widely implemented, but it was very useful. In 2016, our team came together to try to update SAM. And so a lot of what I'm going to talk about today, or I'll talk a little bit about today, is what was that evolution, and that evolution will help you understand where we're going next. And so you can see that starting in 2016, we've had very frequent releases of first we updated SAM 1.1. We addressed the scoring model, and since 2018, we've been working in SAM 2.0. I do believe our current version is 2.1 that finally has some translations and some additional mappings in it. But what's interesting is that between 2009 and 2016, the framework had literally no changes in it whatsoever, which was, I think, indicative of just how far behind it fell and how much work we had ahead of us. The original SAM was governance, construction, verification, deployment. For those of you familiar with waterfall development lifecycle, you will see that that basically follows that process. What you don't see in here are aspects of how software development is actually done today. You don't, if you're trying to do DevOps, you certainly don't see anywhere you can plug those concepts in. So the truth is that the way software is developed has changed. And it's very important to understand the evolution of programming languages as we talk about it. And it's much more fun to do if we were all in the room together, but one great way to understand why we need so many programming languages is to ask all of you guys, what is your favorite text editor? In my experience, there will be at least 5 or 6 in an average room of developers with their own perfect reasons why theirs is the best. Well, once you know how to develop software, you just keep developing and keep enhancing, and it's the culture of an engineer to continuously look for a better, more optimum way of doing things. Well, unfortunately, that also introduces a lot of complexity. Now, a tiny bit of history in OWASP meetings. Usually, you guys don't need this primer, but it is useful to, again, in laying out the concept of SAM. to highlight the differences between compiled and interpreted languages. Compiled, of course, is the world we're coming from. This is traditional, older programming languages like C, C++. Things were require quite a bit more knowledge to be able to code in. So historically, software development was hard to learn. You had to study it in college. It wasn't something you can just Google your way through. Historically, there was no Google. Interpreted programming languages are easier to learn. Well, that easy to learn is a good thing. However, it also introduces a whole wide range of amateurs that are coming in to become developers. From the standpoint of improving diversity of the software development workforce and giving people careers, I think this has been a tremendously positive impact. However, if you did not study programming, you might not have some of the basic knowledge of how to write software well. In fact, I can assure you that it has become way too easy to write software nowadays. I have proof of that. I write software, and I am very much an amateur, and I assure you I do it poorly, but I can still do it. And so allowing so many amateurs to write code has created security risks that need to be accommodated now. Now, compiled languages are faster, inarguable, and interpreted languages are generally slower because as you're running the code, as it's being interpreted, there is some computing power being spent on that. Problem that was wildly addressed through horizontal scaling. So instead of making our code more optimal, we simply learn how to put more resources on it and make it more scalable and add more horsepower to a machine to crunch through it anyways. This is another very big one, is in a compiled application, you had one application for the most part. With interpreted programming languages, you have a very wide range of dependencies that you now have to consider. In fact, now there is actually a term called software supply chain to help understand just how complicated these chains may be. And so if you're developing today an application using any of the more modern JavaScript frameworks, you're potentially pulling in more code than you're writing. In fact, I can almost assure you that you're reusing more code than you're writing. And again, in the compiled languages, there were dependencies, but they were typically commercial, very expensive, and there was at least some sense of accountability, while in the interpreted world, all of our dependencies are open source, or most of our dependencies are open source, which in itself has also caused problems because as dependencies of our applications change from the security perspective, we know that our applications are going to be impacted. So your banking software might be bulletproof, but potentially one of the components your code is using is compromised. And so all of a sudden you're bringing that code in and it now runs in your trusted environment. So as a security professional, all of these things are doing nothing to ease our worries. And so Sam needed to make sure to address all of these things. Of course, in addition to evolution of computing of programming languages, we also have to pause and recognize just how much our computing architecture has changed. I recently had a position working for a data center company, one of Amazon competitors. And I mean, honestly, considering that the organization supported thousands and thousands of servers, I don't think I saw one system that resembled a server that I might work with 15 years ago. Everything is now virtualized. In fact, we're virtualizing virtualization. In case if you didn't realize, that's kind of what Docker is. And then we're virtualizing that on top of things. So with everything getting so virtualized, every single one of those layers has security concerns. And every single one of those layers plays a role in your software development lifecycle. And so again, these are all important considerations for us to keep in mind. Then we get to infrastructure as code. There was a time when building infrastructure required engineering. Well, now software developers are building infrastructure. Everything is being done with scripting. You're using containers, you're using microservices. All of these various components are allowing you to build very sophisticated, very complicated infrastructure in minutes. And just as a lot of engineers and server people of the yesteryear may be bad at software development, I assure you most software developers are really bad at building infrastructure. And so once again, we're talking about a knowledge gap that needs to be closed. In addition to that, the way we build software has changed quite dramatically. I mean, just think about how much we have evolved from the old waterfall concept, where a software development might take 6 months. A software development might take longer than that. And so you spent a considerable amount of time gathering requirements, doing the design, finally somebody goes to build, then you're doing some verification steps, and it's all very, very linear. And think just how much faster we're developing software today, where in a week, you can generally build an application more robust and more powerful than 10 years ago it would have taken a year to do. And so again, this is constantly changing. And SAM started more or less in this waterfall concept where you have requirements, analysis, implementation, verification, deployment. From here, we went to Agile, where you have multiple iterations, but you're still deploying fairly infrequently. And that deployment, this is the piece that from the security perspective, this is what we care a lot about. This is where whatever developers create hits the world. And of course, now we're more in a DevOps model where you're going in a constant circle between idea to deployment. You're deploying, Netflix is everybody's favorite example, but in many cases, you're deploying daily, maybe even multiple times a day. And of course, just to stress security people even more, we're putting cloud in the middle of all of this. But as we were looking at these various frameworks, one of the things that was kind of interesting is in comparing Waterfall, Agile, and DevOps, they were actually, in a way, they were different, but they had very much the same components. They each had a design phase. They each had a coding phase. They each had a testing phase. It's just more about the iteration of each one. And really, the deployment one was kind of the biggest standout because in DevOps, that's the one that fell out of cycle. That's the one that you did very, very, very frequently, which we needed to get some control on. And so a lot of these recognitions have led us to realize that we needed a new business function. So historically, it was governance, design, verification, and operations. And it became very, very clear to us that we needed to accommodate modern software development practices, we needed a new business function called implementation. And so this is the core structure of SAM as it lives today. I won't make you read this slide. I'm actually going to dive into a little bit more detail on each one of these. But you can now see that we're, at least at a high level, you can see that now we're talking about things like secure build, secure deployment, defect management. So suddenly we are now going to be accommodating a lot more of these concepts. So diving in a little more detail, governance. Governance was actually a section that I was responsible for. So I'm going to probably talk about it more than most engineers will ever want to talk about. Strategy and metrics. There are two components that are going to be part of any successful program. First is you have to create your application security as a program in an organization, and you have to promote it. You have to make it very visible to software developers. You have to make it very visible to people so that Developers know where to go for answers, so that as an organization, there is a sense of security. I did multiple security assessments over the years, and it can be very, very demoralizing where you meet with a team of developers and you ask them, where do you go for answers when you have security concerns? And their answer is, nowhere, we figure it out ourselves. And of course, part of any successful program is you have to measure and find ways of documenting that improvement. There was a point in time where in security, you can simply, say the word breach, stomp your foot, and suddenly the organization gave you money. Today, application security and security in general is being measured exactly the same way as any other department in the organization. And so it's very important to think about metrics and think about documenting not only how are you keeping your systems secure, but also how you're improving your operational effectiveness and efficiencies. Policy and compliance. From the policy and compliance standpoint, compliance especially is a beast. There are more and more regulations as more organizations are becoming global that we have to contend with. And so making sure that you have policies to support your rules of conduct that you're trying to enforce, and making sure that you meet compliance requirements are key components. Now, SAM is meant for developers. So why would we put policies and compliance in here? The primary reason is we're not just saying you need policies. Everyone already knows that. What these sections detail out is the need for you to convert your policies and compliance requirements into stories, into requirements, and make sure that you're providing them to software developers in the language that they expect. Historically, compliance people would just take an ISO set of policies, throw them at developers and say, here, make sure your software meets that. Well, that's lazy and very ineffective. What SAM walks you through is how you can actually take your policy requirements, create user stories, create epics, and build a library that can be reused on multiple software developments to make sure that your requirements are actually being met. From the education and guidance, training and awareness, huge component, especially to make sure that training is being provided that's a little bit customized for various groups, so that DBAs would be getting different and more specialized training than your front-end development team. Make sure that people who are responsible for DevOps get training that's custom for their purposes. And in general, from the organization and culture, making sure that you talk about concepts like, Security Champion has been a very good program, very powerful. A lot of organizations have implemented it. But it's really important to try to push past that point at this. Not only go for having security champions in various teams, but really try to build, here the concept is a center of excellence. What I mean by that is you have developers in most organizations that have figured out secure ways of doing things. So if you have a developer somewhere that has built kind of an internal library of, let's say, front-end code libraries that are particularly useful and secure and are now being reused, you want to promote that. At later maturity levels of organization and culture, you really want to focus on promoting developers more than security champions, and really feature positive security practices among the development teams. From the security standpoint, I promise you, if I pick any argument with a software developer, I'm going to lose 10 out of 10. So it's very important to make sure that developers are the ones that we're focusing on when it comes to changing the organization and culture of security. Next up is the design business function. From the design standpoint, first and foremost, we have the threat assessment. Threat assessments are a lost art of software security. In order for you to know whether you're adequately protecting your application, you have to know what threats you're protecting it from. And so within this security practice, we are defining steps for building an application risk profile. Not all applications are the same. Not all applications carry the same risk level. And so it's very important to make sure that you correlate application risks to how much security you're applying to them, and where security exceptions may be appropriate versus not, or how often you pen test, things of that nature. And coming out of application and risk profiles, there's threat modeling. Again, threat modeling is a very important part of the process for you to actually figure out where additional security controls may be necessary. You need to create diagrams. You need to really make sure that for larger organizations, there are actual threat modeling programs that organizations end up implementing just to be able to make sure that their security covers their needs sufficiently. And speaking of security requirements, that kind of takes us to two different aspects of that security practice. Software requirements, which of course go to your actual application objectives. At different maturity levels, the goal is to go from high level to things that are much more prescriptive, and eventually build a more comprehensive requirements framework that various teams can utilize, but also your supplier security. More and more organizations outsource software development, so it's very important to make sure that your security requirements are built into any arrangements with third parties that you may have. And last but certainly not least, security architecture. Now, when we talked about some of the more traditional applications that are compiled that have fewer dependencies, the architecture was for the most part fairly simple. Today, because of the incredibly layered design of most applications, where not only do you have the front end and the back end, but each one of those has many, many layers that all need to work together, it has become increasingly more important to make sure that you really think about the architectural footprint of every application. You want to make sure that you develop and document some design patterns. You want to make sure that you really put some thought into which layers are going to be appropriate, which services are going to be appropriate for your organization, and how you're going to be defending each one of those layers. And partnering that from the technology management standpoint, you want to make sure that you standardize on as many frameworks as possible. So just for easy example, think how many front-end frameworks there are today. Well, if as a large organization you try to support all of them, the chances are you won't be successful. So it's very important to make sure that at some point you start managing the technology by limiting the choices of some of the frameworks that are being used across the applications. And of course, at the most mature level of technology management, you really want to put some very strong guardrails around people using whatever they want. The goal here isn't to stump innovation. The goal here is to make sure that from the security standpoint, you have some control around the components developers are bringing into your applications. Implementation is our newest. And so from that standpoint, I would say most of implementation is really about DevOps. First of all, we really need to talk about the security of the build process. A lot of the application hacks that I have seen do actually happen at build process, where rogue code is being introduced. And very often that rogue code is being introduced through software dependencies. So making sure that you actually spend some time in thinking how you build your software, where you build it. making sure that your pipelines are as automated as they can be, and to make sure that you've taken some measures in detecting if the code being built has been changed from what was pulled out of the code repository. Software dependencies is a huge one. There are many different ways that the organizations are trying to solve this. There are all manners of open source scanning tools that you can leverage, applications that will scan through your source code and try to pull out as many security vulnerabilities as possible. There are organizations that set up their own trusted repositories of dependencies that once they vet them, once they approve them, once they scan them. So one of the interesting solutions that I've seen is they would allow developers for test purposes or development purposes to pull dependencies from anywhere they want. But in order to build in production, those dependencies had to be available on their own code repository, which means their security team had to scan and sign off on every one of the dependencies being used. The most important thing to understand is that your dependencies are an incredible risk to your organization. And so it's very important to make sure you have some processes in place to make sure that those dependencies are being managed. From the security deployment standpoint, the bigger issues here is you really need to think about the deployment process and standardize it. There was a time, again, if you're looking at some more traditional development environments, replicating your, just getting your build to work was a big challenge. Well, today, because we're using a lot more DevOps and we're using infrastructure as code, you're, in a sense, building your environment from scratch and you're deploying it. It's quite a lot of code to deploy. You're actually pushing a lot more changes out than just the things you've changed in your software. And so you really want to make sure that you use automated deployment whenever necessary, remove as much manual interaction as possible. And in using so many different layers in our applications, the new problem we're dealing with is just how many different passwords or API keys or secrets that are now involved in our environment. And so from the maturity standpoint, you want to start by at least making sure that you're not storing any of your credentials in plain text. And of course, as you go down the development maturity model, you really want to make sure that at some point, all of your passwords are being injected at build process. And I believe at maturity level 3, you have to be at a place where your secrets are actually generated and injected at build or at deployment. So at that point, no one can ever know what they are, because every time you deploy, you're essentially changing all of your passwords. Defect management, there's nothing new about defect management as a need, but one thing we do stress is metrics and feedback. And feedback here is the more important piece. From the defect tracking, it's fairly standard, it's fairly traditional. You want to make sure you get to a place where you have some SLAs and you have some standards about what code, what vulnerabilities of code you will allow in production. Metrics and feedback is the more powerful one. Here we have some instructions on how you can build programs of evaluating your defects across multiple applications using similar technology, and feeding that information back to your design business function to see if there are new standards that may be appropriate, or if there are new design or reference architecture that you may want to augment based on how many issues you're seeing. So for example, if you are evaluating it and let's say React framework seems to be experiencing fewer UI bugs than Vue, then that might be a trigger for you to say, you know what, maybe as an organization, we need to move away from a more vulnerable framework towards more secure ones. And so all of that is part of your metrics and feedback that you can establish at this other stream. Moving towards verification, this has always been the bread and butter of most security consulting firms. It's also the one that, from the security perspective, we even traditionally felt the most connected to, because, well, that's what we do. We assess security. And so, but however, in the new world of software development, it's important to make sure that we're not just doing our typical testing, but we're actually assessing the architecture. And so from the security mechanisms that you're using in various components of each application, you want to make sure that you're actually validating that there are no new components being introduced. For those of you that have done some development, you know just how easy it is to add an extra layer into your stack. So it's important that as part of the verification process, we're actually going back and saying, are you using what we thought you were going to be using? Have you slipped any additional components into your application? And as we're looking at every layer in the architecture, making sure that we're looking at each one for any known threats. So for example, if you slipped a Redis server, or if you added any more, components into your build, now we have to go back and look for any known threats, any known vulnerabilities in that scheme. Requirements-driven testing is something that I strongly recommend everyone to try to automate as much as possible. And typical requirements-driven testing for us is really focused on our security controls. So whatever you're using to make sure that your application remains secure, exactly in the same way that you would be testing application functionality, we recommend, from the security perspective, you define test cases. And we literally talk about creating test cases that you can give developers and say, please make sure these are included as part of your testing. And once you automate it, hopefully it's done with every build. In addition to control verification, however, it's also very, very important to introduce misuse and abuse testing, again, as part of that automated test cycle. So that you are doing some basic security fuzzing. You want to make sure that you introduce some logic abuse testing. In the most advanced case, you might even want to consider adding some things that might be more of a denial of service security stress test, just to see how the application reacts under very, very heavy loads. The nice thing is that with the advances in technology and automation of the testing, these things should be built in as much as they can be, to be done a lot more frequently and with a lot stronger regularity. Security testing is more of what you would expect from a pen test. The difference between scalable baseline and deep understanding is scalable baseline focuses more on fully automated testing that could be incorporated in the build process, something that doesn't require a lot of manual interactions at all. As you move down the maturity line, the goal here is to use more and more application-specific security testing tools. But ultimately, we want you to integrate them as much as possible. When it comes to deep understanding, the easiest way of looking at that is a manual penetration test. This is where you have a trained security expert going after your application, trying to break in. And here the maturity is more about going from some specific ad hoc manual testing of very high-risk components, and gradually going into more integrated testing that's part of your overall development lifecycle. Operations has always had a bad reputation in the SAM platform, simply because a lot of developers see operations as something that operations teams should be more involved with. Ultimately, I don't disagree, but you also have to keep in mind that with more and more infrastructure being built by developers through infrastructure as code, you're sort of taking on that responsibility. So it's important that as part of SAM, we do talk about it. Also keep in mind that while SAM has evolved to make sure that we accommodate DevOps and we accommodate some of the newer development methodologies, we also have to continue supporting legacy as well. And so that's where this survived. The first one is incident management. From the incident management, one thing that I'd like you to really pause and think about is how does your what information does your application provide that would allow someone to identify an incident? Do you have enough logs available? Is there a well-established process that someone has thought through on how you can identify malicious activity or fraudulent activity within your application? Also, keep in mind that as security incidents happen, as a developer of an application, your team is going to be involved. And so it's very important to make sure that on every development team, you have people that have been formally designated the responsibility for incident response, and then they have received some additional training to make sure that they know how to respond to incidents. From the environment management, again, this is all about hardening and making sure that the components you're putting out there have been stripped of all things that are unnecessary. Any services you're not actively using been shut off, and making sure that you provide sufficient guidance to developers or operations teams in knowing exactly how to lock things down. Patching and updating also takes a very different outlook when it comes to software development and DevOps, because if you're thinking about traditional software development environment, scanning a Docker container for vulnerabilities is certainly doable, and there are tools that are increasingly give you opportunities to do that more and more diligently. By their very nature, these containers are destroyed and rebuilt all the time. And so making sure that from the patching and updating standpoint, you have worked out ways for you to monitor versions of all of the various components and layers within your application, and you're keeping them up to date, is critical. And that finally brings us to the operational management. The first component is data protection. Data privacy has been driving the agenda, I would say, for the last 3, 4, 5 years. Really driving that agenda. And so we want to make sure that as part of your application development lifecycle, you have basic data practices in place, you're sanitizing test data appropriately, you have data catalogs developed so that you actually know where the various sensitive data may be stored and what that data contains. And finally, decommissioning. As applications get decommissioned, as various layers get decommissioned, we provide some additional guidance on how legacy systems and decommissioned systems should be shut down. If you've ever been involved, if you've ever done any kind of assessments of security for organizations, finding these half-dead but still working applications that contain sensitive data happens all the time. And so it was very important that SAM contains language and guidance on best ways of including that in your overall program. The best way for you to get more information on every one of the things that I had talked about right now, and by the way, I'm still happy to answer any of the questions you're going to have, is for you to go to our website, owaspsam.org. One of the things that we did, which is really kind of neat, is we actually deployed the entire framework through GitHub. So what better way to embrace DevOps than to actually make the entire SAM framework built by way of DevOps. So the way the entire framework is managed is we have this core where we have markdown files and YAML files that contain the entire framework. And so every single time we make changes to the framework, whether it's additional guidance or mapping or anything else, we're actually running actions in real time that go behind the scenes and will rebuild the website, rebuild all of our tools, regenerate the survey spreadsheet that we're using right now to conduct SAM assessments, and update every one of the SAM artifacts. So it's a really interesting new way of managing a security framework. Security frameworks are notoriously stale and they don't update very often. With SAM, we really wanted to create something that can update as often as infrequently as software world changes. And so that's how we're doing that. One of the nice side benefits of that is if you are trying to implement SAM in your organization, you can actually build your own life cycles to monitor our core model, which, as I mentioned before, is all data files. And so you can very easily build your own tools and build your own integrations to be able to take SAM and bring it into any format you want in your own organization. So definitely something worth thinking about. And that community involvement is critical. SAM framework consists of a lot of various components. We have business functions. Those are the 5 components that I had talked about. Each one of those has 3 security practices. Within each security practice, we have defined 2 different streams. These streams are meant to be kind of 2 different strategies of you implementing that specific component, and helping you mirror reaching 3 different maturity levels of each one of those components. It sounds more complicated than it really is, so I suggest I would really recommend everyone to actually take time and go and read what the SAM framework has, and all of these things will become very clear to you. As you read every one of these, as you dive into the details, you're going to see some benefits. You're going to see activities that we recommend that will give you something that's very prescriptive. We also give you questions you can ask to help assess whether you're meeting the intent of this requirement or not. Quality criteria are simply ways of providing more background on how your question is being interpreted and the typical answers. Now, if you want to do your own SAM assessment, you certainly don't need to go and harvest this information on your own. You can actually download our toolkit, which is available on GitHub, that will take you through that assessment. We really are always looking for community support. Our future goals are to make sure that we supplement the SAM framework with references to tools, specific metrics, any kind of dependencies, any additional guidance. We spent a lot of time trying to map SAM against other OWASP projects, so that if you're trying to improve, let's say, a threat modeling, you're going to find references from threat modeling SAM requirements to the threat modeling projects in OWASP to make sure that we can actually connect those dots for you. So the model is intended to continue its evolution, and the more community support we get, the more and better it's going to evolve. We're also in the process of getting the SAM translated. It's being done through the Crowdon project. As you can see, Russian is not one of the languages listed, so we're still looking for volunteers. I would volunteer, but my Russian is not very good anymore. So we're definitely looking for some native Russian speakers who would be interested in partnering up and getting SAM translated. One of the other really cool aspects of SAM we're working on is how to benchmark. One of the things that if you guys have seen BSIM, which is a very similar framework to SAM, except it's been privatized. One of the nicest things about it is that it gives you comparative analysis, so you can see how your organization is doing across the industry. Well, these kinds of, it's easy to do when you have a single organization that controls the entire framework, because OWASP is very open. We really historically didn't have a lot of ways to collect that information, and so a gentleman by the name Brian Glass, he is now really pushing forward to get our benchmarking in line. And to do that, he is working with organizations that are willing to share their assessments, anonymously, of course. And so you can look forward to seeing a lot more from us in this area in how we can publish some comparative benchmarks. Our roadmap specifically, right now we're in 2.1. This is kind of our ongoing, where we're focused mostly on translation and mapping the framework. Later in the fall of this year, our goal is to release 2.2, which is then going to have some more activity-specific guidance and references. In 2022, tentatively, we would like to launch an online toolbox. Right now, the toolbox is a spreadsheet. I have been working in that spreadsheet for a long time. It's massive, but it does work. We also want to get to a place of having an open API so that you can actually query all of this information online and not have to rely on pulling down YAML files. And version 3, we don't know yet. So again, we're closely watching what the community wants from us, and so we're going to try to accommodate that. There are a lot of different ways you guys can get involved. We have monthly community calls, second Wednesday of every month. Please check out our GitHub. We actually have a new home. Follow us on Twitter, LinkedIn, you name it. So we're definitely in all the predictable areas where you would expect us. And so with that, I think I've talked long enough. I'd love to open it up to some questions.
Ян, спасибо большое за интересный рассказ. Действительно, давайте приступим к вопросам. Мы успели собрать приблизительно несколько из них. В частности, давайте начнем сразу с того, что поменялось и что было добавлено во второй версии OWASP, а именно концепции стримов. Это вносит часто некое замешательство. Вот, собственно, можете, пожалуйста, чуть подробнее рассказать, какова их роль и как их можно применять?
В принципе, роль стримов заключается в том, чтобы дать... Дело в том, что, вот, к примеру, смотрим на такое понятие, как threat assessment. Threat assessment — это дисциплина, которая, если говорить о threats и при этом не говорить про application risk profile, это значит, что ты теряешь половину информации. И это очень просто хороший пример, где с точки зрения maturity, то есть мы говорим о том, что при первом уровне это best effort, просто попытайся определить, где твои самые большие проблемы. При втором уровне мы говорим, что нужно иметь какие-то стандарты по всей организации, чтобы все программы пересматривались систематично, чтобы это не было ad hoc или one-off. И при третьем речь уже идет о том, чтобы именно proactively смотреть на все risks, на все threats, и при этом смотреть в будущее. Ну, как вы понимаете, при трех этих maturity levels они сами по себе не дают достаточно информации. И поэтому вот эти два стрима, они просто дают две параллельные мысли, которые должны разрабатываться одновременно. То есть, с одной стороны, вы разрабатываете, как вы смотрите на application profiles. Изначально, может быть, вы просто пытаетесь понять, какая программа имеет доступ к какой информации. А при более серьезных уровнях вы уже начинаете смотреть на функциональность этой программы, вы можете начинать ее разбивать на конкретно, если эта программа кем-то будет пробита, какой импакт будет на вашу организацию. И threat modeling должно идти параллельно к application risk profiling. То есть при том, как вы выявляете, какие риски в ваших программах, вы должны пересматривать всю архитектуру вашей программы и смотреть, какие threats могут быть там выявлены. То есть, в принципе, тут ничего сногсшибательного сложного нету. Мы сделали несколько стримов, просто чтобы помочь людям внедрять все эти программы.
Можно ли достичь, например, третьего уровня, там, не знаю, например, Defect Management activity, можно ли достичь, например, третьего уровня, выполнив только один стрим? Или он предполагает под собой, что это просто как бы разные по специфике активности, но оба стрима, вот это как бы, по сути, две дороги, которые ведут на самом деле к одному, и по обоим из них нужно двигаться?
Правильно, нужно по ним двигаться одновременно, потому что если, к примеру, вы пришли к какому-то continuous optimizing and automating of threat modeling, но при этом у вас нету очень advanced application risk profiling, то это будет неправильно внедренная система.
То есть получается, что эти вот два грузовика по этим двум дорогам, не только они должны ехать, но они еще и должны синхронизироваться.
Да. Единственное место, где, честно скажу, это у нас немножко развязано, это operational management, потому что там эти два стрима, они их мало что связывают, но для симметрии нам нужно было заполнить бланки.
Понятно. Тогда давайте переходим уже к следующему вопросу. Конкретно у нас интересует, кстати, Defect Management, первый уровень зрелости, maturity level, и конкретно там есть такой quality criteria. Do you use the basic metrics about recorded security defects to carry out quick wins, improvements and activities? И вот этот вот самый quick win, он часто может ввести, опять же, замешательство разностью толкования. Вот что в данном случае понимается под quick wins?
Quick win would be, это, его еще также в английском языке такая фраза low-hanging fruit. То есть это вещи, которые очень легко устранить. То есть, к примеру, там, перекрывание слабых протоколов.
Или включение глобального энкодинга для защиты от XSS.
То есть это вещи, которые вы используете фреймворк, где вы правильно включили какой-то флажок, и вдруг целая схема пришла к вам. То есть это рассчитано более на такие low-hanging fruit вещи, которые очень-очень легко и быстро выясняются.
Понятно. Хорошо. Следующий вопрос. Уже переходим к архитектуре. Есть, собственно, уже activity, называется Architectural Assessment. И в частности, конкретно уже стрим, по-моему, стрим, да, Architecture Mitigation и третий уровень зрелости. И там упоминается, собственно, reference architectures. Do you regularly update your reference architectures based on architecture assessment findings? Вот что в данном случае имеется в виду под этой практикой? Вот reference architecture и assessment findings.
Ну, то есть все начинается с того, что, во-первых, нужно иметь reference architecture, которая каким-то образом зафиксирована, которая передается программистам, чтобы они по ней шли. То есть все, в принципе, начинается с этого процесса. Вот дам более конкретный пример. Я работал с компанией, они долго к этому шли, но они, в принципе, вывели стандарт, что они будут использовать только две front-end frameworks. И они разработали кучу документации на reference architecture, которая все смотрела, то есть именно на эти две frameworks, как они работают, как их использовать, какие компоненты могут там участвовать. И после нескольких лет, после того, как их убивали на penetration tests, они поняли, что на самом деле, то есть когда они делают вот эти вот reviews, они понимают, что одна из frameworks более слабая, чем другая. И что, исходя из этого, они начали пытаться всех перевести на другую architecture. То есть смысл здесь заключается в том, что после того, как вы внедрили reference architecture, после того, как вы сделали все эти стандарты должны периодически пересматриваться. И когда вы их пересматриваете, вы должны активно собирать информацию со всех команд, что вы видите, когда вы делаете pen-тест, что вы видите, когда вы делаете security assessments, когда вы делаете code reviews, какие проблемы вы выявляете, и можно ли некоторые из этих проблем решить тем, чтобы просто изменить architectural requirements, чтобы эти проблемы больше в систему вообще не входили.
Ну, то есть под reference от architecture здесь понимается такое типовая архитектура, и которая распространена в компании, и на базе нее строится там какой-то пул приложений, и вот эта архитектура из-за того, что она такая достаточно высокоуровневая сущность, она и должна быть, опять же, пересматриваться регулярно в зависимости от изменений.
И также эта архитектура должна пересматривать external interconnectivity. То есть, когда когда особенно в больших компаниях, где у вас все программы друг с другом разговаривают, также часть вот этой reference architecture это стандартизировать на том, какие, допустим, у вас может есть 3 разных метода делать authentication, но есть один метод, который preferred. То есть часть вот этой вот reference architecture это с точки зрения logging, с точки зрения authentication, вот эти вот shared services, чтобы также были стандарты, которые внедрялись везде.
Понятно. Следующий вопрос. Мы уже перепрыгиваем на configuration hardening, и в частности здесь есть такой вопрос, и как quality критерия для этой activity. Do you harden configurations for key components of your technology stacks? Вот key components of your technology stacks, это вот что в данном случае понимается?
Ну, к примеру, вы строите простую, я не знаю, программку, которая front-end, back-end, база данных где-то сидит. Front-end может быть несколько уровней, там где-то Nginx, где-то Redis может сидит, база данных, там есть свои компоненты. Backend framework имеет свои компоненты. Каждый из этих компонентов может быть hardened. То есть в базе данных нужно выключить определенные services, нужно менять вот эти вот пароли некоторые. Front-end есть определенные флажки, которые обязательно нужно поставить, чтобы security компоненты работали. Есть определенные команды, которые нужно прошивать в Nginx, чтобы опять устранить вот эти вот самые типичные common vulnerabilities. Если есть services, которые вы не используете, их нужно перекрывать. Буквально вот если посмотреть в детали каждого из этих layers, вы можете найти кучу разных best practices о том, как устранять все вот эти вот самые типичные проблемы. Вот это то, что мы подразумеваем под hardening. Hardening — это значит сделать всю систему менее уязвимой и как можно больше стремиться к понятию whitelisting, то есть все закрыто, кроме того, что абсолютно необходимо для функциональности.
Ну, пример с Nginx из базы данных как раз был достаточно понятен. У нас осталось совсем чуть-чуть вопросов, они уже носят более такой общий характер, но при этом практически с точки зрения понимания OWASP. Смотрите, вот у вас большой опыт. Какие вы могли бы дать советы по внедрению SAM? Такие жизненные, да, вот как можно избежать, возможно, каких-то подводных камней, которые часто, можно не споткнуться, часто на эти грабли наступают. И вот, может быть, какие-то есть такие вот советы, которые можно было бы распространить таким образом и облегчить жизнь всем тем, кто задумывается о внедрении OWASP.
Хороший вопрос. В принципе, что вам нужно для внедрения SAM? Это в первую очередь вам нужно иметь очень хорошие отношения с вашими developers. Вам нужно именно строить partnerships. Вы никогда не сможете внедрить эффективно SAM, если вы не будете иметь какого-то общего языка с людьми, которые будут ваши номер один пользователи этой системы.
Это, кстати, интересный момент, что пользователь номер один, это, получается, разработчики, developers.
Тут сложно. Дело в том, что, по крайней мере, я видел очень часто, это все... Вот когда я смотрю на... Особенно вот для этого очень легко продается implementation, business function. Почему? Потому что для того, чтобы вам подняться до определенного уровня maturity в implementation, нужно, чтобы было очень много автоматизации в вашем build and deploy процессе. Автоматизация в build and deploy, и, кстати, также в verification, особенно если мы говорим про requirements-driven testing. Эта автоматизация подразумевает, что у вас будут, tools, у вас будут toys, у вас будет orchestration система, у вас будет много вот этих вот sophisticated tools. Также скажу честно, программисты терпеть не могут разбираться с bugs. Всем намного интереснее разрабатывать новую функциональность, чем копаться в, извините за выражение, дерьме и искать проблемы, которые были кем-то сделаны много лет назад. Поэтому нужно просто, когда вы подходите к модели как этой, вам нужно подойти к этому с точки зрения cooperation. То есть как мы будем работать вместе, как вы можете им облегчить работу и как они могут вам облегчить жизнь. Вам нужна transparency с точки зрения security, то есть если я security professional, мне нужно знать, что они делают. Мне нужно знать, как они это делают. Я хочу знать, что все мои concerns с точки зрения dependencies, build process, credentials, hardening, чтобы все это было соблюдалось. Взамен я им могу дать больше причин покупать разные toys, которые они хотят. я могу дать им requirements, написанные на языке, который для них более приемлем. Я могу им дать test scripts, которые написаны на языке более для них приемлемым. То есть тут нужно именно работать над partnership. Еще что очень хорошо работает, это понятие gamification. Gamification это Сэм очень легко делать, на самом деле. Просто нужно продумать этот вопрос немножко. Это было, наверное, пару лет назад, я пытался разработать схему, по которой можно было запускать Сэм таким образом, чтобы assessments были сделаны на каждую программу индивидуально. То есть, в принципе, Сэм, как он сейчас построен, он сделан для того, чтобы делать maturity score на целую организацию, на всю компанию. Но, разумеется, как все понимают, то есть для маленьких компаний, где у вас там 5-10 разработок, это нормально. Но если это большая корпорация, где у вас может быть программ несколько тысяч, сотни точно. Я работал с одним из глобальных банков Северной Америки, и они посчитали, у них было 2500 разработок. Так, это те, которых они знали. Разумеется, сделать какой-то maturity score на всю организацию невозможно. То есть тут нужно продумать, как разбить организацию на маленькие, может быть, это departments, может быть, это divisions, может, это development teams, и делать assessments более на индивидуальном уровне. Также хорошо продумать, какие metrics можно увязать, и опять, с точки зрения SAM, это одна из вещей, которые мы хотим помочь, то есть мы будем предлагать разные metrics, которые будут подходить ко всем этим security practices. Но также неплохо продумать, какие metrics вы можете собирать, которые вам могут более явно выявлять, если определенная security practice или stream правильно внедрены или нет. И строить как можно больше dashboards, которые будут всю эту информацию выявлять. Это, конечно, у меня есть немного больше деталей насчет того, именно как это можно внедрить, потому что, опять, у меня вся эта система проработана, я делал много assessments на эту тему. Наверное, в наш разговор сейчас это плохо входит, но я бы сказал, что всем, кому это интересно, кто работает в больших организациях, и вы именно хотите конкретно посмотреть, как можно это более эффективно внедрить, я бы всем порекомендовал, просто киньте мне email, свяжитесь со мной, и я с большим удовольствием вам помогу, я вам пришлю немного больше информации о том, именно как это внедрять в более больших enterprises. Потому что действительно это в какой-то момент не так просто, но в то же самое время это очень doable, и я уже видел много организаций, которые очень успешно это все внедрили.
Понятно. Кстати, следующий вопрос. Кажется, что вы отчасти на него уже ответили. Он звучит так. Это как раз что вот нам сейчас присылали вопросы. И какой первый шаг лучше всего делать для того, чтобы на пути к внедрению SAM в какой-то конкретной организации? Если я правильно услышал, то этим шагом может быть хорошее такое знакомство и отношение с разработчиками.
Первый шаг – это, безусловно, вам нужно, чтобы я порекомендовал, это именно встретиться с разработчиками, с архитектами и сказать им о том, что вот, посмотрите, вот есть такая схема, которая разрабатывается комьюнити. То есть это не мы, злые гении, а это комьюнити вам предлагает схему, по которой мы можем действительно улучшать процесс, по которому программы разрабатываются. И уникальность SAM-модели это в том, что эта модель не построена, как традиционные security frameworks работают как. Сидит security человек, который говорит, вот, ты инженер, вот то, что ты должен делать для меня. И эта схема с разработчиками просто не работает. Ну, она, в принципе, и с инженерами никогда не работала. Но с разработчиками она тем более не работает, потому что, опять есть такая очень замечательная фраза, это люди и вода всегда найдут самый легкий путь. Поэтому чем больше вы барьеров будете ставить, тем больше они просто вас обойдут стороной. Что мне нравится в SAM, это то, что эту модель мы построили более cooperative, где вопрос не идет о том, что вы им говорите вам что-то делать, а вы им помогаете, как это внедрить, как это лучше сделать. Может быть, вы им помогаете дать justification, чтобы они купили какие-то tools, которые им нужны. Опять я уже раньше говорил, что там policy and compliance, то есть само понятие того, что вы им приносите не policies, а вы им приносите test scripts, вы им приносите requirements, stories, epics. Я работал с одной организацией, мы сделали библиотеку стандартных security requirements, которые они просто могли, и они использовали Jira везде, и они просто могли взять целые огромные компоненты и прямо затолкнуть их к себе в Jira, и все. Им больше не надо ни о чем волноваться. У них все requirements на месте, они сразу пошли, все пробежали по нескольким, разбили на несколько спринтов, и мы знали, что все компоненты на месте. То есть чем больше вы можете предлагать решений, которые именно помогают разработчикам это все внедрять. То есть вы не просто им говорите, вот мои требования. Но для того, чтобы начать этот разговор, нужно, конечно, взять какой-то buy-in. То есть нужно, чтобы их эта схема заинтересовала. Нужно найти людей, которые вам помогут. Потому что, да, у security всегда тяжелая работа в этом смысле.
Да, и особенно тяжело стараться быть другом, разработчиком, а не вот тем человеком, который портит им жизнь.
Ну, кстати, ты знаешь, Тарас, вот одну вещь я порекомендую, это любому человеку, который будет работать с программистами, именно в этой capacity, я очень рекомендую найди какой-то класс на Udemy или где-нибудь еще и научись программировать. То есть никогда программистом не будешь. Но вот возьми и сделай там самую такую элементарную фронт-энд программку. Возьми, поставь себе vagrant на систему, запусти самый такой элементарный Devops. Разберись, как работает, если ты никогда не работал с Git, разберись, как работает Code Repository. Разберись, как работает orchestration на самом минимальном уровне. И когда ты будешь использовать более грамотный словарь при работе с программистами, они начнут с тобой разговаривать.
Я на самом деле полностью поддерживаю эту идею, и я также согласен с тем, что application security инженер – это буквально тот человек, который должен говорить с разработчиками на одном с ним языке. Причем этот язык, он не только национальный язык, но это и те языки, на которых разрабатываются в этой компании.
Абсолютно верно.
Если этого не будет, всегда разработчик будет воспринимать IT-security инженера как какого-то человека со стороны. И будет очень сложно ему доказывать, что вот эту штуку нужно сделать. Почему? И вот это доказательство будет гораздо сложнее сделать. Ну что ж, давайте на самом деле заканчивать. Я хотел бы поблагодарить еще раз Яна за то, что у нас получился такой интересный разговор про OWASP. Еще больше поблагодарить за то, что у нас получилась такая интересная секция вопросов и ответов. В заключение хотел сказать вот что. Как было, опять же, в докладе обращено внимание, у OWASP сейчас уже есть переводы, но нет перевода на русский язык. И у этого замечательного проекта, причем этого проекта такого фундаментального, такого фреймворка для построения, по сути, программы безопасности, того самого SDLC в вашей компании, вот у вас есть отличная возможность для того, чтобы сделать его более понятным, более широко используем, например, в России. Присоединяйтесь к проекту, собственно, как минимум это можно сделать на уровне перевода через платформу Crowdwind, которая упоминалась. Могу сказать в конце, что еще раз спасибо за выступление, и давайте заканчивать. До новых всем встреч. Все внедряем SDLC, а вас всем.
Всего хорошего. Спасибо.
Да, всего хорошего.